Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. Right. In a previous sessions, we discussed about the signals and their representations. Right. We started what is a signal, right? How to represent the signal, and what are the test signals, what are the laboratory generated signals. So what are the step signals, what are the test signals, step signal, ramp signal, parabolic signals. We already studied about modal representation and mathematical equation for each and every signals, test signals, right? After that, the second category of the signals, that is nothing but a periodic signal. What is a periodic signal? What is non-periodic signal? So what is a condition to satisfy the periodic signal? So what is the difference between a periodic and non-periodic signal? Right. After that, what are the rules to find whether the signal is a periodic signal or else non-periodic signal? If the signal is a periodic signal, so what is a time period? Right. So there is a continuous signal and a discontinuous signals to represent the periodic and non-periodic signals. So these are the things that we discussed in our previous sessions. Now today we are going to discuss about the modulation. Right. In this session, so what I'm going to deal about means, so what is a modulation? So I'm going to give the definition of modulation. Right. Second, what is the need of modulation? Right. So what is the need of modulation? Different types of modulation. So what are the different types of modulation? So in this session, so we are going to deal about these three things. So what is the concept is modulation. Right. So the concept is modulation. So in this session we are going to discuss about actually what is a modulation. Right? What is the importance of a modulation? It means what is the need of a modulation? So need is nothing but advantages also we covered in this. And what are the different types of modulation techniques? That's we discussed here. The first will go for a modulation. Right. So we know that. So we can't transfer the low frequency signal for a large distance. So that means we can't transfer the low frequency signal for large distance. That means so what voice signals is that what I am speaking? Voice signal. You know about voice signal, which is a frequency of 20 Hz to 20 kilohertz. So this is very low frequency, right? In electronics, the frequency should be high means the size is very less. We'll see, that's another concept, right? So whatever the voice signal, so which is 20 Hz to 20 kilohertz, so that is very less frequency. So if you want to transfer what I am speaking here, so it can't be transferred. These type of low frequency signal for a large distance, like if you are staying in Machala, so it can't transfer. So what should I do to transfer my signal from Nellore to Machala? It's very difficult. So how it can be transferred means only high frequency signals can be transferred to a large distance. You know that only high frequency signal can be transferred to a large distances. Right? So what we should do for my low frequency signal to transfer large distances? That means you have to combine this low frequency signal with high frequency signal in order to transfer a large distances. So that process we can call it as a modulation. Alright, so I'll define one more time. So you have a low frequency signal, right? So this is not transferred for a large distances, right? But we need to transfer. So what we should do? So we need to take a high frequency signal. So we have to take high frequency signal. So that signal we can call it as a carrier signal. Right? So that signal we can call it as a carrier signal. Very, very important. So the carrier signal is always high frequency signal. So you have to match this low frequency signal to high frequency signal. So that means match that low frequency signal with high frequency signal. So then this signal is going to be transferred for a large distance. The process of combining low frequency signal with high frequency signal, we can call it as a modulation. Alright, so I will define. So the process of combine low frequency signal, so that is called a message signal. So that means my input signal. So what is a message signal? Voice signal, right? With high frequency signal. So that we can call it as a carrier signal. So the matching, the process of matching, we can call it as modulation. Right? So the process of combining low frequency signal with high frequency signal, so we can call it as a modulation in order to transfer for a large distances, right? So you have a voice signal that is 20 Hz to 20 kilohertz. So it's very difficult to transfer for a large distances. That means you have to choose a carrier signal, so which is having a 2 megahertz, 2 gigahertz frequencies that you have to choose. Then combine. So according to my message signal, my carrier signal is varied. So that means the matching in order to get the output. So in order to get the transfer the signal for a large distance. So this process, the matching process, so we can call it as a modulation. I hope it's clear. Alright? See. Now we have to define some simple block diagram. What is a modulation means? So this is my input. For suppose my signal is like this. This is my message signal. Right? So this is my message signal. So that is nothing but low frequency signal. For suppose I've got 50 kilohertz. So this is very low. So we can't transfer for a large distances. So that means you have to combine high frequency signal. So that we can call it as a carrier signal. So that means high frequency signal, how the signal will be look like. So whatever it may be, right? So that means this is a high frequency signal. So this combination we can call it as a modulating. So modulation. The output you are getting is a modulated wave. Right? So this we can transfer for a large distances. Right? So here once again, what are the parts in a modulation means? So modulation which is having an input signal, so that is called a message signal. That is nothing but low frequency signal. So without a carrier signal, you won't transfer this for a larger distances, right? So that means we require a carrier signal which is having high frequency. High frequency means very less time period, right? So these process, the combination, the combining this low frequency signal with high frequency signal. So that process we can call it as a modulation. The resultant signal, so that is called modulated signal. Alright, so that is called a modulated signal. So I hope it's clear what is a message signal, what is a carrier signal, what is a modulated signal. I hope it's clear. Alright, now so this is the definition of a modulation. Now we are going to why we require a modulation. Right? Why we need modulation. Right? In that, the first point is over. That means why we require low frequency signal we can't transfer. But we need to transfer this signal, so that we require a modulation. But suppose you know about stone and paper relationship, right? This is a stone now. Stone, right? This is a paper, right? So the paper, which is a low frequency signal, stone, which is a high frequency signal. You are assuming that's some example, right? Right? The paper alone, so we can't transfer for a large distances. Paper distance maximum koncham distance, some little distance will alone paper. So paper alone we can't transfer for a large distances, right? You can transfer for a little distances, but we require to transfer this paper from Nellore to Macharla. It's very difficult, paper alone. So that means we have to, so ఈ పేపర్కి స్టోన్ కనెక్ట్ చేసి స్టోన్ చుట్టామనుకో, సో ద కాంబినేషన్ ఆఫ్ పేపర్ విత్ స్టోన్స్ మడిచామంటూ వీ కెన్ ట్రాన్స్ఫర్ ఫర్ ఎ లార్జ్ డిస్టెన్సెస్. సో ద కాంబినేషన్ పేపర్ విత్ స్టోన్స్, so we can transfer for a large distances. So that process of combination of paper and stone we can call it as a modulation. I hope it's clear from this example itself, right? So the paper alone we can transfer because which is very less weight as a low frequency component. So the stone which is having high frequency components, a paper ni stone ki chuttamanko, so we can transfer for a large distances. So that process we can call it as a modulation. So what is this stone? Stone is a high frequency signal, so that is called a carrier signal. Right? So this is called a carrier signal, and this is called a message signal. The resultant that we are getting a signal which is called a modulated signal, so that we can transfer for a large distances. Right? And first point over. And what is the second point? Right? If it is a low frequency, it's very difficult to transfer. Or else if you want to transfer without modulation, you require height of the antenna should be very high. That means some sort of 20 kilometers of antenna for 20 hertz, 20 kilohertz, 20 kilometers of antenna that you require. Height of the antenna, 20 kilometers of height of the antenna that you require in order to transfer the low frequency signal, so without a modulation. So that means how much height? 20 kilometers high. Is it possible? Definitely not possible. A very cost based issue. So if this low frequency is combined with the high frequency signal, so you require antenna height of 3.5 meters is enough. 3.5 meters of antenna is enough to transfer these signals, right? So that is one of the important requirement for the modulation. And after that, disturbances. The third one is disturbances rejected. That means if I have a device 1 and I have a device 2, right? So if the signal is not modulated, right, that is a low frequency signal. So that means that is a low frequency signal. So you are transmit this low frequency signals, that is my 20 kilohertz signal. So that signal is going on. For suppose you built an antenna very height and you are transmitting this signal, right? Another device is there. So that device also transmit the signal of 20 kilohertz. So definitely what happened? These two signals are going to be combined. Definitely there will be a noise, disturbances will be created. Right? So if you modulate it, right? Now if you apply a modulation, that means this 20 kilohertz signal is compared with a high frequency signal. So you have to check whether the signal output is 83.1 kilohertz or it is 89.1 kilohertz. So these two signals frequencies are different when you got modulation here. Definitely these two signals won't contact anywhere. So there is any contact? No contact anywhere. Definitely the disturbances will be rejected. Right? That means if you won't modulated the signal, definitely those two frequency signals will be connected at anywhere in a air. So definitely there will be a disturbances will occur. If you modulated means each and every device is that it has some frequency is going to be substituted. After the process of modulation, so these two different frequencies won't connect at each other. So that means that the disturbances will be rejected. So that's the third modulation process. That is the third need of a modulation. And after that, the fourth one. After that, so that definitely the noise will be eliminated. So noise will be eliminated. Right? These are the need of a modulation purposes. Right? So what is the need of a modulation purposes? The first one is, alright, what is the need of a modulation means? That means a low frequency components we can't transfer. So the first purpose with the modulation purpose only, so we can transfer for a large distance. So the antenna tower height. So if you use a low frequency signal, the tower of antenna should be very high. Right? That can be avoided. So the disturbances can be avoided with the help of modulation and noise rejections. Right? The cost also reduces. The fifth one is complexity will be reduces. The circuit complexity reduces, cost reduces. These are the need for a modulation. Now we'll discuss what are the different types of the modulation. Right? So with this I will finish the session. Right? So what the modulation types? Right? So there are two types of modulation. The first one is continuous type modulation, continuous signal modulation, right? Pulse modulation, right? So continuous signal modulation means the carrier wave which you are using high frequency, which is in a continuous mode, continuous type. Here the carrier wave which is used in a pulse type, right? Pulse means this one, continuous means sinusoidal, right? So continuous signal, there are further classified into three types. So that is nothing but each and every continuous signal that it has some amplitude na, frequency na, phase na, right? So from this we classified as amplitude modulation, frequency modulation, and the third one is a phase modulation, right? So the continuous type, which is having a three components: what is the amplitude of this one, what is the phase difference of this one, what is the frequency of this one. So with this, the modulations are categorized as amplitude modulation, frequency modulation, and phase modulation. Alright. Pulse modulation basically categorized into two types. The first one is analog modulation, analog phase modulation, and digital phase modulation. Right? The digital modulation, another classified is into one type, that's it. That is called pulse code modulation. So the digital modulation further classified into another type, that is called a pulse code modulation. Right? So analog phase modulation is categorized into two types. Right? So what are the types? PWM, we discussed in your power electronics in this pulse width modulation, right? And another type, so this is nothing but pulse width modulation. So another type is a pulse time modulation. So PTM, so the digital modulation is a PCM, right? Analog modulations are again two types. So what are the types of pulse width modulation and pulse time modulation, right? And one more model is there, so that is called PPM, pulse position modulation. So this is called pulse width modulation. So this is called pulse time modulation. So this is called pulse position modulation. So basically modulation are two types: the continuous signal modulation and pulse modulation. Continuous signal modulation means carrier wave is a continuous wave, right? Carrier wave is a pulse wave. So again, continuous signal modulation classified into three types: amplitude modulation, frequency modulation, phase modulation, right? Pulse modulation again two types, so those are analog modulation and digital modulation. So the digital modulation is a PCM, that means pulse code modulation. We'll discuss, this is very very important concept. So only this thing we have in our syllabus, right? Pulse code modulation, right? Analog modulation is two types. So the first one is a pulse width modulation and pulse time modulation and pulse position modulation. So this is about different types of a modulation, right? I'm going to explain one more time. So what is a modulation means? Low frequency signal is combined with the high frequency signal, right, in order to transfer the signal for large distances, right? Per suppose if you want to transfer your message signal, so that you have a message signal, so the message signal is like this. So you need to transfer this message signal. For that you have a high frequency carrier signal. So you have to combine this message signal with a high frequency signal. So this carrier wave will change. This carrier wave will change the amplitude and frequency. I said earlier, the carrier wave which is having a continuous signal, which is having amplitude, frequency, but the but my message signal won't be changed. When combine this message signal with a carrier wave, according to the function, my carrier wave will change only, not the message signal, and the resultant signal will be obtained. That signal will be transferred for a large distances. So that is the concept of so that is called a modulated signal. So that is a carrier signal. So this will change, but this signal won't be changed because this signal we need to transfer. Right? Which one is changes means only carrier wave will change instantaneous values of the message signal. We'll discuss different types so you will clearly understand. Basically, what is a modulation means? High frequency signal is combined with a low frequency signal. So that process we can call it as a modulation. Alright, so this is called modulation. Alright, so about this session, these are the things that we discussed. In the next session, so we have a syllabus wrap. What is the amplitude modulation? What is a frequency modulation? What is a phase modulation? And what is a PCM? Pulse code modulation. Samples and whole circuit is there. That's not that much important. So in the next session we are going to discuss about these three. What is the amplitude modulation? What is a frequency modulation? What is a phase modulation? And after that, what is a pulse code modulation? We'll discuss. With this we'll finish this concept, finish this unit, right? I hope it's clear as per my knowledge, because this is a electronics subject. Alright, and the next session we discussed about types of modulation. Thank you very much.